Good evening, all. Audio, video, okay now? Okay. So let's start. Today we'll be doing problems from organometallic compounds. So organometallic compounds and coordination chemistry, they are very well interconnected. So we'll start. Then already questions. I have posted it. So just a second. Okay. So this is the first type of question that you will be getting. Everything related 18 electron rule. Now, what is 18 electron rule? 18 electron rule mainly when you count the valence electrons contributed from the metal and from the ligands, a total of 18 electrons should be obtained. 18 electron that complex is known to be well stable. Chala cases, there are certain complexes, especially square planar complexes, where our stability our 18 electron even with the 16 electrons, it can form stable configuration. Okay, so main exams in 18 electron rules in the question it's already included in section number 3. Initially, namaka basic easier questions. Okay, so I hope the videos of OMCs were available. Sir, more assignments are there, so I'm not discussing those solutions. The video solution is already there in the app. So you can check that if you want. Other variations and higher versions. All right. So this question says you have to find the metal, especially that it belongs to the 3D series. In the question already showed it, and you have to use 18 electron rule as your guide. Okay. So to find the 18 electron rule, you have to find what is the contribution. So what is this ligand? This ligand, as you can see, it is a ligand with 5 carbon atoms, and a metal connecting ligand in the middle portion. There are different ways in which you can show the attachment. Either it can be like this, or it could be like this. So, the difference between these two representations are, the metal is connected to only one carbon, but even the metal is connected to the middle portion, which means it is connected, it is bonded to all the 5 carbon atoms. So, extra atoms in all are the binding other than the electronic contribution. So here you can see that in the 5 carbons are the binding. So the contribution of this ligand over here is 5, and the contribution of this ligand is a cyclobutadiene. Metal is again connected to all the 4 carbon atoms, and the contribution is 4. So you have to find the metal, you have to find the 3D metal such a way that it satisfies the 18 electron. Okay, so 5 plus 4 is 9. If it has to follow the 18 electron rule, metal contribute into the electrons, it should contribute 9 electrons. 9 electrons contribute to total 18 hours. So to find that, you should know what the metal is. What is which contributes 9 electrons? Which metal contributes 9 electrons? Yes. So, that it is a 3D series. So, 3D series are D7S2 cobalt. D7S2, a total of 9 electrons cobalt. Okay. So, this is very easy. This is how you have to find it. In a question, they can ask you to find the oxidation state of the metal. Now, knowing the oxidation state of the metal is not important at all when you consider the neutral atom method. Be very careful. In the question, that you have to do with this method, that is neutral atom method or ionic method or in case in upcoming exams, ionic method in the contribution. Okay, so this is the usual method that you use, which is a neutral atom method, and this is very easy. Let's say, okay, I hope that is fine. Neutral atom method, oxidation state. In oxidation state, what will we do? So, how will you find the oxidation state? All these rings over here, it will try to attain aromaticity. So, to attain aromaticity, what is to be done? See, this has 5 electrons, 5 carbons, so 5 pi electrons. So, to attain aromaticity, it has to take 1 more electron. So, the formal charge of the species is -1. Here, 4 pi electrons are. And to attain aromaticity, everything, closed ring systems which are under conjugation, aromaticity is formal charge. So, in cyclopentadienyl, already 5 electrons in conjugation aromatic. So, its contribution is, its charge is -1. Cyclobutadiene already 4 pi electrons are and to attain aromaticity, accept. Then only it will become 2. So, -1, -2. Total ligand in the charge is -3. So, metal in the oxidation state will be +3. So, sherikim ivada cobalt in the oxidation state is +3. Okay. So, this is how you do questions. Very easy. Okay. Try the next question. Find the contribution as well as. So, what 18 electron rule, you should know the contributions of each and every ligand. So, what is the next question? There is a metal attached to cyclopentadienyl. Cyclopentadienyl, the formal charge -1, and the contribution 5. Now, this ligand over here, be very careful with this ligand. This is NO. NO ligand can exist in 2 conformations. So, NO linear right. So, linear right NO. I have already explained this. Linear right NO, the charge is plus and its contribution is 3. Bent if it is bent, the charge is minus and its contribution is 1. Okay. So, can you solve and find which metal is this, right? Yes, so if a contribution from NO, this is going to be 3. 5 plus 3 is 8. So this requires 18 ആണ് വേണ്ടത് 10 വേണം. So 10 വേണമെന്നാണെങ്കിൽ it should have B10S, B8S2. B8S2, which corresponds to nickel. What is oxidation state? This is -1, even +1. So total ligands moolamula formal charge is 0. So metal is also 0. All right. Is it okay for those who are not familiar with such questions? Is this okay? Are you clear? Everybody? Nivedita, Sinju, I hope it is fine. നിങ്ങൾക്ക് doubt ഉണ്ടെന്നാണെങ്കിൽ please ask. കേട്ടോ? Yeah, so the ബാക്കിയുള്ളവർ they have watched the videos, so it might be a bit easier for them. But still, നിങ്ങൾക്ക് doubt ഉണ്ടെന്നാണെങ്കിൽ you can ask. All right? Okay. Next question, very easy. Cyclopentadienyl charge and contribution നിങ്ങൾക്ക് അറിയാം. Carbonyl is a neutral ligand. That means whose formal charge is 0. And carbonyl always contributes 2. So, cyclopentadienyl contributes 5. 3 carbonyl മൂലം 3 into 2 contributes 6. So, metal should contribute 11 plus 7. P5S2 3D iron. That is manganese. What would be the oxidation state? Even -1 and this is neutral. So the charge on this complex is going to be +1. Manganese is in +1 oxidation state. Okay, good. Can you try it with oxidation state? Next one, easy. Next is very easy. You have 5 carbonyls. 5 carbonyls. Now this is neutral, so the metal which was present will also be in 0 oxidation state. And 5 carbonyls ആണുള്ളത്. 5 into 2 will give you 10 electrons. 8 electrons satisfied, this should be 8, which means it should be 3d6 4s2. And this is going to be iron in 0 oxidation state. Iron. Okay. Next one. Charge വരുമ്പോ അവനെയും കൺസിഡർ ചെയ്യണം. നല്ല മഴ പെയ്യുന്നുണ്ട്. If there is any problem regarding the connection, please let me know. Yes, so the next one is you have 7 carbonyls, 7 into 2, 14. And ഇവിടെ there is plus. Plus എന്ന് വെച്ചാൽ ഒരെണ്ണം പോയി. ഒരു ഇലക്ട്രോൺ ഈ സിസ്റ്റത്തിൽ നിന്ന് പോയി. So 14 minus 1, 13 ആണ്. So in order to have 18 electron rule, it should have 5 electrons, which means it should be 3d3 4s2, which is vanadium. What is the oxidation state of vanadium over here? Carbonyl 0 ആണ്, പക്ഷേ the whole complex is plus. So this should be plus, vanadium plus. Yes. Is it fine? Good. Next question. This is important. What is given over here is a metal which is double bonded to one of the ligand. Now, in a system, this is known as a carbene system. M double bond C with two attachments. This is a carbene system. And you can also have M triple bond Cr, which is a carbine system. Now, ഇവിടെ ആരാണെങ്കിലും okay, R groups H ആയിക്കോട്ടെ, phenyl ആയിക്കോട്ടെ, methyl ആയിക്കോട്ടെ, ആരും ആയിക്കോട്ടെ, this portion over here, this carbene portion over here, ഈ portion പറയുന്നതാണ് carbene ligand. അപ്പൊ ഇവിടെ ആര് കാർബണിന്റെ കൂടെ ആര് വന്നാലും ഇവിടെ C ആണ് മെറ്റൽ ആയിട്ട് ബോണ്ട് ഫോം ചെയ്യുന്നത് ലിഗാൻഡിന്റെ. Okay, so when you have a carbene complex, ഇതിന്റെ formal charge is -2, ഇവിടെ -3. And even the contribution over here is 2 electrons. Even the contribution over here is 3 electrons. Okay. So now you can try, right? Don't consider the ligands which are over here. Other E carbene in the bhagana. So that does not matter. Even if it is hydrogen, even if it is just methyl, even if it is phenyl, that is not going to affect the contribution of this carbene. Carbene, it will contribute 2 electrons. All right. So yes, right. Try it with the oxidation state. So carbene in the contribution, you have 2 electron contributions, and ഇവിടെ 5 into 2 10. അപ്പോൾ മൊത്തം 12 ആയി. ഇനി നിങ്ങൾക്ക് ഇവിടെ എന്താ വേണ്ടേ? It should have 6. അല്ലേ? 6 ആണെങ്കിൽ 3d4 4s2. ആരാള്? Chromium. Correct. What is oxidation state? This carbonyl is neutral. Carbene portion in there is -2. As a whole complex is 0, neutral. So this should be +2. Chromium is in +2 oxidation state. Okay, so this is the first type of question that you will be getting. In the upcoming sessions of the previous year questions, you will understand that you will be given for the 3D and read the question well. They can even ask you about a 4D, they can ask you about 5D, whatever it is. You have to read the questions. Using 18 electron rule, you have to identify which metal is present in the complex. Okay, now let's go to the next type of question where you need to find the charge of the complex. So, that's it. So here what they have given is they have already mentioned which metal is there. In order to, again, 18 electron rule then a guide you have to find what is the charge of the complex. All right. So I will show one and you can do the remaining. So you have cobalt in the system. So cobalt, it is 3d74s2. So this will contribute 9. You have 3 carbonyls, 3 into 2, 6. And 9 plus 6 gives you 15. You have to satisfy the 18 electron rule. In order to satisfy the 18 electron rule, what should be the value of the charge? So, ഇവിടെ 15 ആയിട്ടുള്ള 3 electron കൂടെ വരണം അല്ലേ? 3 electron കൂടെ ഈ സിസ്റ്റത്തിലേക്ക് വരണം, which means it will have a total of -3. All right. Yes. Do the next one. You have ruthenium in the system. Ruthenium. Iron, ruthenium, osmium. Iron, ruthenium, osmium. Iron and then iron is 3d6 4s2. But ruthenium will be 4d6 5s2. Right? Now, what is this ligand which is given over here? Carbon is familiar. You have SIME thrice. So don't worry, just like you have CH3 methyl. Methyl group in the formal charge formal charge of methyl group is -1 and whose contribution is 1 electron. For CH3 ki pagaram, let's say they give you CR3. R can be anything, methyl and thing. Now, formal charge -1 1 electron. In carbon, that group silicon. So instead of C, let's say you have SiR3, the properties are the same. There's a formal charge of -1 and whose contribution is 1 electron. Okay? Chedolo? Yes, so ruthenium, as we said, it belongs to iron group D6S2. So 8 plus 8, 16 plus 1, 17. You need to have only one more electron. So this is going to be -1. Yes. Next question. Now pay attention. This is not a carbine. It's a carbine. Carbine it should have been iron triple bond CH. This is a carbine system. This is not a carbine system. You have C triple bond CH. This is bound to iron and carbonyl and CP ring. So whenever you see a question, chuma triple bond system carbine. So even a contribution pi electrons. So alkyne system contributes 2 electrons. Yeah. Right? Done? Yes. So here, this is 2 electrons. Even you can have 5, even 2, even 2. Iron is 8. 8 10, 15, 17, 19. You need only 18. It should have +1. Easy. Okay, very good. You're doing well. Next question. Manganese bromide CON times. Now see how the question has changed. നമ്മൾ നേരത്തെ ചെയ്തുകൊണ്ടിരുന്നത് using 18 electron rule as a guide, you used to find what is the charge of the complex. Instead, ഇവർ പറഞ്ഞിട്ടുള്ളത് you have to find the number of ligands. Already നിങ്ങൾക്ക് അറിയാം that each carbonyl contributes 2 electrons. So here what are they saying? ഇവിടെ എത്ര ligands ആയിരിക്കും ഉണ്ടാവുക in order to satisfy the 18 electron rule, right? Yes, so manganese is a D5S2 system. This contributes 7, this contributes 1, 8I. So this should contribute in a total of 10. So 10 varanam nanengil each contributes 2, so N is equal to 5. Yes. Next type of question. See, next type of question here, it's not the number of ligands. This is actually something related to the type of the ligand. In the type of the ligand, I can join here such that that satisfies the 8 electron rule. What is the type? Yes, so eta 5, C5H5, even the cyclopentadienyl, this contributes 5, cobalt contributes 9, 9 plus 5, 14. This should contribute 4. 4 are contributing, what would be the hapticity? It should be cyclobutadiene system. So N is equal to 4. Okay. Last question, this is finding the hapticities. Again, finding hapticities means etra carbons it is bound, that would be the hapticity. You have tungsten in the system, chromium, molybdenum, tungsten. They belong to the same group. Chromium, molybdenum, tungsten. Yes, so chromium, molybdenum, tungsten, D4S26. This contributes 4. So this is a total of 10. Up ഇവിടുന്ന് 8 ആണ് വരേണ്ടത്. Cyclopentadienyl ring has mainly 3 hapticities, 1, 3 and 5. ഇതാണ് commonly കണ്ടുവരുന്നത്. So if it should have a total of 8, ഒരാള് 3 ഉം ഒരാള് 5 ഉം ആകാനാണ് chance. Anything. 5 and 3. Okay, I hope the hapticities are clear. നിങ്ങൾക്ക് ഇങ്ങനെയാണ് വരുന്നതെങ്കിൽ hapticity is 1. 3 മാത്രമാണ് കണക്ഷൻ ആയിട്ട് വരുന്നതെങ്കിൽ hapticity is 3. And 5 പേരുമായിട്ടുള്ള കണക്ഷൻ ആണെങ്കിൽ ഇങ്ങനെ വരും. So this is eta 1, this is eta 3, this is eta 5. Okay. Try the next one. Yeah, so ruthenium, iron, ruthenium, osmium, which is 8. This is, okay, you have to find. So this is a total of and the benzene systems are X and Y. So it should give a total of 10. And 10 of course, you have to give 6 for one, which is the maximum hapticity, and the other one can be 4. So 6 and 4. Okay, so 18 electron rule as a guide, they can ask you to find the charge of the complex, the number of the ligand, hapticity, to find which metal it is, or the type of the ligand. Three type of questions are 18 electron rule in matram vara chance. Is that okay? Is that okay to all? All right. So let's move to the next set. So in this set, what we will be doing is 18 electron rule in the matturu application to find how many metal-metal bonds are there in the system. So as we said, if the last question, the number of metal which was present is just 1. Or at in the yeah, it had only just one metal. So let's say there are more than one metal. About more than one metal, why we have to consider this? Because if you have one mm bond, the mm bond rand electrons will contribute towards the 18 electron. So if you have one mm bond, it will contribute 2 electrons. If you have M double bond N, that will contribute 4 electrons. If you have M triple bond M, it will contribute 6 electrons, and so on. Each MM bond will contribute 2 electrons. Okay. Now, that's the metal bond already in system 18 electron rule satisfy in the parayyanengil, you will be able to find the number of bonds. How will you be able to find the number of bonds? 18 into the number of metals which are present minus the total valence electrons divided by 2 will give you the number of metal-metal bonds. This is the equation. Oh. So can we start? Let's start by solving problem. Mn twice CO 10 times. So നമ്മുടെ കയ്യിൽ 2 manganese ആണുള്ളത്. You know manganese is 7. 7 into 2 14. 10 carbonyl 10 into 2 20. So how do you put it into equation? 18 into 2. And in the value of 2 ആണ്. 18 into 2 is 36. Minus 14 plus 20. That's the total valence electrons we count. So 34 divided by 2. What is the answer? 2 by 2, 1. Which means the system has one metal-metal bond in the system. Ingane structure Mn, Mn. Ingane one metal-metal bond under, and to each metal 5 carbonyls are attached. This is the structure of the system. Yes, try the next one. Cobalt. Cobalt 9 ആണെന്ന് നമുക്കറിയാം. 9 into 2 18. 8 into 2 16. When you add this, you will get 34. How many metals are there? You have 2 metals. 36 minus 34 divided by 2. Again, there is only one metal-metal bond in the system. Is it okay? Okay, try the next one. Cobalt 4 times. So the number of the number of metals in the system is equal to 4. Yes, so cobalt, how many electrons does it has? So it is 9 into 4, you will get 36. 12 into 2, 24. So you have 18 into 4, which is 18 into 4 is 72 minus 60 divided by 2. 12 by 2, 6. Cobalt bonds are there. Next question. Tungsten, chromium, molybdenum, tungsten. ശ്രദ്ധിക്കണേ, രണ്ടാണ് ഇവിടെ 2. രണ്ട് പേരുണ്ട്. So chromium, molybdenum, tungsten. 6. 6 into 2, 12. 2 Cp, which is 10. MuCl, very important. When you have chloride, its contribution is 1. When you have mu chloride, its contribution is 3. When you have mu2 chloride, its contribution is 5. Mu means bridging. So MuCl രണ്ട് പേരാണുള്ളത്. 3 into 2, 6. കാർബണിൽ ഇവിടെ 2. So മൊത്തം 4. 4 into 2, 8. Calculate. So you have a total of 36, which was expected. Actually, 12 plus 10, 22. 22 plus 14, 36. Okay, yeah. Number of metal bonds is equal to 0. Clear? Is it fine? Yeah. Next question. Try. Cp രണ്ടെണ്ണം 10. Iron രണ്ടെണ്ണം 16. Carbonyl രണ്ടെണ്ണം 4. Nitrosyl രണ്ടെണ്ണം 3 into 2, 6. So 26 plus 10, 36. Again, 0. Next question. You have 2 molybdenum in the system. So this is 10. Chromium, molybdenum, tungsten is 6 into 2, 12. 6 into 2, 12. This is 24 plus 10, 34. 36 minus 34 by 2. 1. കിട്ടുണ്ടോ? സ്പീഡ് കൂടുണ്ടോ എന്റെ? കിട്ടുണ്ടോ? 1. Do the 7th one. Okay. Next question. In the ചോദിച്ചിട്ടുള്ള question ആണ്. So tungsten രണ്ടെണ്ണം വരുമ്പോൾ 12 ആണ് വരിക. And OR, OH പോലെ തന്നെ OR contributes 1 electron. അങ്ങനെ 1 ആണ് നമ്മൾ substitute ചെയ്യുന്നതെങ്കിൽ 6 ആയി. 1 into 6, 6 ആയി. So this is a total of 18. നമുക്ക് എത്ര വേണ്ടേ? 36 ആണ് എക്സ്പെക്ട് ചെയ്യുന്നത്. 18 into 2 minus 18 by 2. എന്ന് വെച്ചാൽ 9. Okay. So having 9 bonds between 2 tungstens or possible അല്ല. ഇപ്പൊ നിങ്ങൾക്ക് ക്വസ്റ്റ്യനിൽ ചോദിച്ചപ്പോഴും it was not there. 9 എന്ന് പറഞ്ഞൊരു ഓപ്ഷൻ ഉണ്ടായിരുന്നില്ല. So what you have to consider is OH, as we said, just like chloride, വെറുതെ OR contributes 1 electron, and there is mu OR which contributes 3 electrons. അപ്പൊ നമ്മൾ 1 electron എടുത്തപ്പോഴാണ് നമുക്ക് 9 ആയിട്ട് കിട്ടുന്നത്. You put 3 electrons because 9 എന്ന് പറയുന്നത് ഒരു ഓപ്ഷനിൽ ഉണ്ടായിരുന്നില്ല. You put 3 and then find the answer. How many electrons? 3. Sorry. How many bonds? 3. So it will become 6 into 3, 18. 18 plus 12, 30. 36 minus 30 by 2, you will get 3. Next question. Manganese. എത്രണ്ണ? 3 manganese ഉണ്ട്. So that is 7 into 3, 21. Mu pH2 ആണ്. That is 3 into 3, 9. Carbonal 12. 12 into 4 into 3, 12. 12 into 2, 23. So 18 into 3, 54 minus. എത്ര കിട്ടുന്നത്? 30 plus 54. അല്ലേ? 21 plus 9, 30, 0. Okay, next question. Do it on your own. Tell me. So you have 4 carbonyls, 8. Vanadium is the 3s2, 5. Rand PR2, which is mu, so this is 6. This is 5. This is 8. Rand metals, rand vanadium ulladu. Rand vanadium aagumbo it will give you a total of 36 minus 8 plus 8, 16. 16 plus 6, 24. 24 plus 10, 34. 1 alle 2 ആണോ? തെറ്റി എനിക്ക്. 1. What is the mistake I have done? 8 plus 8, 16. 16 plus 6, 24 item. Sorry. 32. Correct. Yeah. Now, see the next question. This is a variation. They have given that the number of nickel-nickel bonds in the system is equal to 3, and you have to find the total charge of the system. So, how do you do this now? Now, already you know that if you have N metals in the system, the total electronic configuration that it should attain for stability is 18N. Okay, so if just 1 metal is there, it follows 18. 2 metals are 36, 3 are 54, 4 are 72, and so on. So if it has 3 metal ions, so it should have a total of 54 electrons. Total 54. Okay. Now already, okay, now try to do this on your own. Yes, everybody. How do we do this? So you have 3 into 5, 15. Nickel is D8S2 system. So that will give you nickel, 3. So that will give you 30. 3 nickel bonds and each metal bond will give you 2. And carbonyl. Carbon will give only 2 electrons, even if it is bridging. So mu3 bridging is 4. So 10, and this is 30, 40, 55. You need only 54 in the system. So if it is 54, that is +1. All right. Yeah. Next question. Try. Yes, Lindsay, new student now. Lindsay Francis. Others, please try. You have 1 metal-metal bond in the system, which will contribute 2 electrons. PP 2, So that will give me 10. Osmium. Osmium belongs to which family? Iron, ruthenium, osmium. Oh, yeah. So 8 into 2, 16. You have, this will contribute to N. മൊത്തം 2n ഉണ്ട്. മൊത്തം 2n electrons ഉണ്ട്. Each will contribute 2 electrons. So this is 4n. Okay. So how much is it? This is 26 plus 2, 28 plus 4n should be equal to random metal ആണുള്ളത് 34, 36. So 4n is equal to 36 minus 28, which is 8. N is equal to 2. N is equal to, yes, all right. Last question. You have to find which metal it is. It has just one metal-metal bond in the system. And you have to find, identify the metal which belongs to the 3D series. Yes. So you have one metal-metal bond in the system which contributes to. You have 2 benzene in the system, 6 into 2, 12. And you have 4 carbonyls in total, which will give you 8. So 12 plus 8 is 20. 20 plus 2 is 22. So 36 minus 22 by 2, which is equal to, how much should it contribute? This is 14 by 2. ഒരാള് 7 electrons ഇതാണ് കൊടുക്കേണ്ടത്. Because you have 2 metals. 7 കൊടുക്കുന്നത് ആരാ? Manganese. All right. Yes. So is this clear? Till this much? Oh, so in the question paper which I have already posted, in the group, I have already attached 5 more questions. So those 5 questions have been asked in the previous year. You know that try the session in the video. Get out. We'll discuss in the next session. So for today, we'll wind up. If you have any doubts, you can ask. You can stay back. Otherwise, we'll wind up today's session. Thank you.